Let's discuss about angular displacement. Look here, there's this object here at A moving in a circular motion, okay? Now, when you move from A to B, it would have traveled angle theta from the center, right? So, let's say the radius of this circle is R, the distance traveled is S. So we say the angular displacement theta. Now, this is what we call angular displacement. Okay, it's an angle. Okay, and usually we say it in radian. Okay, we do not say in degrees. Okay. Now, what is this relationship between S, R, and theta? Do you still remember? For this in this secondary 4, you have learned that this is S, this is R, this is theta. Now, you should use the formula S equals to R theta. S is in meter, R also in meter, theta is in radian, right? If I tell you, oh, what is 1 radian? What is 1 radian? 1 radian times 1 meter equals to 1 meter, right? So what is the definition for radian? 1 radian, or simply theta, is the ratio of S and R when their ratio are the same, right? So we want to define what is 1 radian. The 1 radian is defined as this. Is the angle subtended to the center of a circle by an equal in length to the radius. So theta is S over R. Define radian means define 1 radian. Okay, 1 radian equals to 1 meter divided by 1 meter, right? So S is the arc length, R is the radius, okay? It's just like that. You see, you must write this full statement here because this one came out in A level. All right. Now let's look back at this one. Okay. Now, since you know that S equals to R theta, if we both divide by time, what do you get? You get S over T is what? S, the displacement over time, is called the velocity. The velocity is R. Theta over T is the how much angle it travel per second. How much angle travel per second? We give it a new term called angular velocity. This is angular velocity. You see how I draw this one? This is omega in what is called omega. It's not W. W is like that. It's sharp end. This is curly like that. Okay, omega. All right. So this is a very important equation for you to understand about V equals to R omega. Imagine I have another person here. Let's say another person is here. Let's say this position C moving at this arc here. Okay, let's say moving on the same arc. Let's say I draw a smaller circle here. Okay, from C to D, Okay, let's say the travel displacement from here to here is S2. Okay, now I want to ask you a similar question. For A to travel to B, let's say it takes 2 seconds. From C travel to D, let's say it also travel 2 seconds. Who has greater angular velocity? Tell me. Both from here to here traveled with only 2 seconds, both the same time of travel. The answer must be the same, right? Because omega is theta over t. T both also take 2 seconds. Theta travel, both also travel with the same theta. Correct or not? Here to here, they take theta. Here to here, also take theta. Here to here, take 2 seconds. Here to here, also take 2 seconds. In other words, omega is the same for both. They both have same angular velocity. Well, does that mean they have same velocity? What is velocity? Velocity is this. This is the displacement travel over time, right? So velocity is tangent to the path at this point. At this point, what's the velocity? Tangent to the path. At this point, what is the velocity? Tangent to the path, all right? So similarly, this velocity here is tangent to the path. This is tangent to the path. Okay, let's say this is V1. This is V2. This is V2. Here is V2. This is V2. Okay, let's say they're moving at uniform velocity. Okay, tell me, V1 bigger or V2 bigger? V1 bigger or V2 bigger? These two, just compare them. You see, this one you need to travel such a large distance, okay, a large displacement. Yeah, in 2 seconds. This one you need to travel such a short distance, also in 2 seconds. Which one must travel faster? Obviously, V1 must be greater, right? Okay, so it's actually tally with this expression because V1 equals to R1 omega, V2 equals to R2 omega. You see that? V1 is the first one here. R1 is this radius is much larger, right? R2 is V2, V2 is R2. This is the R2. R2 is much shorter. So you compare them and they have the same omega. Obviously, V1 is larger than V2 since R1 is greater than R2. Let's recap on what I've told you just now. What is angular velocity omega? Linear velocity is V. What is the relationship between omega and V? Now look at omega, or angular velocity, is the rate of change of angular displacement in radians, okay, with respect to time. Now this is omega. Omega is simply how much angle travel in 1 second. This must be in radian. It is not in degree, okay? Now look at your notes. It is similar. So again, look at this one. This is the V. This is the R. This is the theta, okay? So this is the same as what I've explained to you just now, all right? We start from our definition. S equals to R theta. Just a quick revision. S equals to R theta is our starting definition. So we divide by time. Divide by time. S over T is V. R theta over T is omega. Omega. Please do not forget. Omega, see, omega is theta over T, right? Theta. What is theta? Theta is the angle travel. What if I travel this in one round? What if I travel it in one round? What is the angle travel? The angle travel is 2 pi radians, right? 2 pi radians. What is the time we call it? When the object travel in one round, what is the time we call it? We call it a period, right? A period. Period is the time to complete one cycle or one oscillation, right? But do you still remember period? Period also equals to 1 over frequency, right? So this becomes 1 over frequency. So it finally becomes 2 pi f. So we have multiple forms here, either 2 pi f or 2 pi over t that represents omega, and you can sub inside here to solve multiple types of questions.